Sometimes we're interested in the equality of two ratios. This is when we're going to be dealing with what's called a proportion. Proportions are going to be particularly useful for us to solve for some unknown quantity, but that we know is going to maintain the same ratio as something else. So for example, if we know the ratio of some given number to 3 is the same as the ratio from 16 to 6, we can solve for that number. The first thing we need to do is to describe this unknown given number with a letter. Typically, we just call this x. When it's written that the ratio x to 3 tells us that we would write x over 3. The fact that we know it's the same means that we can set this equal to the ratio 16 to 6. It's very important that you set up your ratios consistently so that you are actually solving the proportion correctly. To solve these, we're going to use cross multiplication. So I'm going to multiply the 6 to the x, and I'm going to multiply the 3 to the 16. Now, even though cross multiplication is a shortcut here, we really are simply eliminating our denominators. So it's not anything that is invalid algebraically, but it is a shortcut that we're using here. So now we know that 6x equals 48, and we can solve this by dividing both sides by 6, and we know that this unknown answer is 8. Another application that comes up here is in things like blueprints, where we have a scale ratio that's going to be consistent for all parts of that blueprint. We would want to know what the scale is. So here we know that on the blueprint, 25 feet is represented by 2 inches. So we're going to make a ratio feet to inches, and we're going to keep that consistent. So if I know that there are 25 feet for 2 inches, then I would set up the other part of my proportion with what I know. I want the actual distance, so I don't know how many feet there are, but I do know on the map they are 5 inches apart. So notice here that I have my feet in the numerator for both parts of these ratios, and my inches in the denominator in both parts. That's essential that you set these up consistently. Now, we don't have to pay attention to the units anymore now that we have set them up appropriately. So we cross multiply just looking at our numbers. 5 times 25 is 125, and 2 times x is 2x. We can divide both sides by 2, and so our final answer is 62.5. Now this one, the units are important, so we would want to make sure that we include our units in the answer. We were looking for the unknown number of feet, and so this represents 62.5 feet. We can also use proportions to solve things like example 7, where we know a particular alloy is so many parts of one material to so many parts of another material. We have to be careful with the way we set up this proportion to make sure that we have it set up to solve for what it is that we want to know. We're given that it's 5 parts tin to 2 parts lead. But what we actually want to know is how many parts there are of each material for a total of 35 kilograms of the combined alloy. So that doesn't make sense anymore for us to have tin to lead. We actually want to know how much tin there is for the total and how much lead there would be for the total. So the way you would set this up is you could set up parts 10 to the total parts. And so that would be 5 parts 10 and a total of 7 parts, because you have 5 and 2 parts for a total of 7. Now you can solve for the weight of 10 that we don't know but we want to know, and then for the total weight, which is 35 kilograms. We cross multiply and solve this. 35 times 5 is 175, and that equals 7x. And so that tells us here, I'm going to divide both sides by 7, telling me that I have 25 kilograms of tin. Now I could set this up again and do 2 to 7 for my lead to total, but I don't have to. If I know that there's 35 kilograms total, and I just found that 25 of them was 10, then that remains 10 kilograms left over of lead to get that total 35.